Okay, so in this question 2 raised to 256 by 17, and you need to see the remainder, right? So 2 raised to n number, what you will do, you will factorize the numerator in such a way that when you divide with the denominator, leaves +1 or -1 as a remainder, right? And here if you see the denominator, it's 17. So if you need to get +1 as a remainder, you should get 18. If you need to get -1 as a remainder, you should get 16, right? So I know 2 raised to 4 will give me 16, right? So here there is a scope of getting a -1 remainder, -1 remainder. If you write 2 raised to 4 by 17, right? And then you will get remainder for this as -1, right? Or actual remainder is 16, but to make the calculation easier, we'll take it as -1, right? Then how will you write this? 2 raised to 4 raised to 64 by 17, right? And I know that 2 raised to 4 by 17 will give me -1 as a remainder. How many times? 64 times, right? So -1 raised to even number will give me a remainder 1. What if it is 260? Then this will become 65, right? So -1 raised to 65 it will come. That means 2 raised to 4 divided by 17 is -1. That is therefore 65 times. This is odd number, so that will leave a -1 remainder. So -1 will not be there in your option because there is no possibility of getting negative remainder, right? You cannot get negative remainder, so you need to convert it to 16. So if it is 2 raised to 60, your answer is 16. Basically -1 is the answer. You will convert into your real number which you need to get from the option, right? 16 is the answer. Now what if it is 2 raised to 261 divided by 17? Then you will write it in the same way. 2 raised to 4 raised to 65 divided by 17. Okay, perfectly fine. Up to 260 is covered. Then you will write it as 2, right? Into 2. So you know this much, you will get some remainder, right? You get -1 as a remainder. And -1 raised to 65, if you do, you'll get -1 as a remainder. Then you apply the basic remainder theorem that we have discussed. Into 2, you'll get -2 as a remainder. But -2 you cannot get, right? So what you will do, you will take the difference from 17. That means 15 as your answer. Otherwise you can directly find it here also. In the first case you are getting 16 as a remainder, then 2 is there, so 2, that means 32, right? 32 is greater than 17, so further you divide with 17 and see the remainder, then also you'll get 15, right? So what if it was 2 raised to 262 divided by 17? Then you write it as 2 raised to 4 divided by 17. This will be 65 itself. Up to 260 is covered, right? Into 2 square. Then -1 into 4, which is -4. Take the difference, right? You get 13 as your answer. So that's how you'll find any number now. Now in case of the previous question that we have solved, 7 raised to 84 divided by 342, right? So instead of 342, had it been 344, if the question was 7 raised to 84 divided by 344, find the remainder, what you will do? You will write in the same way, right? 7 raised to 3 raised to 28 divided by 344. So here you know that this is going to give you a -1 as a remainder. So basically 7 raised to 3 is 343. 343 divided by 344. 343 itself is a remainder. But to make the calculation easier, I'll take it as -1. Now -1 raised to 28, I get the answer as 1. Because -1 raised to even. Now had it been 87, 7 raised to 87, then this 28 become 29. This 28 become 29. Then this +1 become -1. So -1 is the remainder. But you cannot find -1 in your option. So your option, if you need to convert this -1, it will become 344 -1, that is 343. Now next question, what they're saying, 347, you are dividing successively by 347 and leaves the remainder 2, 1, 4 respectively, right? So I told you, you need to write in this order. We had enough discussion about this topic, successive division, right? Separately we did a lot of discussion. So how will you proceed? You will start from here, diagonally you will multiply, right? And vertically you will add, right? Then again you will multiply, 51. Then vertically you will add, you will get 53. So what is the first possible number? 53 is the first possible number, right? So 53 is the first possible number. And now what is the next number? See, here 3, 4, 7 are the divisors, So LCM of 3, 4, 7, which is 84, right? And first number is 53, LCM is 84. That means this is going to make a AP, this is going to make a series with the first term as 53 and common difference as 84, right? This is a series. We have discussed this type of questions a lot, right? So this is an AP. If you need to get the next term, you add 84, next term you add 84 again 84, so you keep on adding, it's an AP, right? Now any question which can be asked in an AP can be asked here. They can ask about first term, they can ask about common difference, they can ask about nth term, right? A plus n minus 1 into d. They can ask about how many such terms are there within a range of 1000. So you need to find the last term in that range, then last minus first divided by common difference plus 1 will give you the answer, right? And we have seen all these questions, but what they're asking here now, they're asking you what is the remainder when 84 divide the same number. So what is your answer? What is this 84? 84 is nothing but the difference, right? 84 is nothing but the common difference, and there is nothing but the LCM. So we have discussed about constant remainder theorem also, right? What is that? If you have an AP, you take any term from the AP, divide with the common difference. In all cases, you'll get the same remainder, right? So I told you this is going to make an AP with a common difference 84. So all the terms are having a common difference of 84. So all the terms will give you the same remainder when divided by 84. And we know the first term, which is 53. So if you divide 53 by 84, see what is the remainder? 53. And that will be the remainder if you take any term and divide by 84. What is the logic? Constant remainder theorem. You take any term from the AP, divide by the common difference, same as the remainder. So I have taken I know the first term, so I took the first term, I divided by the common difference, I got the remainder as 53. What does this mean? Any term if you take from that AP, it will leave the same remainder, 53. So I don't know in this case what is n. What they are saying is n is a number which when divided successively by 3, 4, 7 leaves remainder 2, 2 and 4 respectively. So 53 is the first such possible number which satisfies the condition. 53 is not the only number, right? There are many numbers, so anyone can be that number. But whatever be the number, if you divide with 84, leaves the same remainder. Why? Because it forms an AP with a common difference of 84. And then we apply constant remainder theorem. Now, instead of if the question is, what will be the remainder if the same number is divided by let's say 10. Let's say 10. Then your answer is cannot be determined. Why? Because if you take the first term 53, you divide by 10, what is answer? You divide by 10, your answer is 3. You get remainder 3, right? You are what is the second term? 53 plus 84. That if you take and divide by 10, you get the remainder as 7. So 3 and 7, two different remainders you got. If you take the third term, you get a third remainder. So you cannot predict what is the remainder, okay? So you cannot determine what is the remainder. But instead of 84, if they are asking about 42, then can you find the answer? You can find the answer, again applying constant remainder theorem, right? So what is constant remainder theorem? You take an AP, take any term from the AP, divide with the common difference, leaves the same remainder in all case. And not only the common difference, all the factors of the common difference will also give you the same remainder. Now if you look here, 84 is the common difference and 42 is the factor of the common difference. So if you divide any term from the AP with 42, then also you'll get the same remainder. And I know the first term is 53, right? So I take out 53, divide with 42, see what is the remainder? 11. Now if you take any term from the AP, divide with 84, or rather 42, I'll get the same remainder 11 only. And not only for 42, if you take 21, 21 is also a factor of 84. You divide the first term with 21, that is 53 divided by 21. See what is the remainder? Again you get 11 as a remainder. And 11 will be the remainder if you take any term from the AP divided by 21. So if the question is about, here question is you divide a number successively by 3, 4, 7 leaves remainder 2 and 4 respectively. What is the remainder when the same number divided by 84? We don't know what is the number, we just know a number. This has to satisfy the condition, divide 3, 4, 7 successively leaves remainder 2 and 4 respectively, right? So we understood that 53 is the first possible number. The other numbers are like the series. The series, anything is coming in the series will satisfy the condition. So if the question is about if 84 divide the number, answer is based on this only, first number only, or any number which is related to 84 in terms of factors, or I put it in this way, any factors of 84 can also be asked here. You can find the answer. So it can be 42, it can be 21, it can be 4, it can be 2, or whatever it is, you can find the answer based on this first term itself. Because if you know the first term, if you can find the remainder in case of first term, same will be the remainder in all cases. But if I take any other number other than the factor of 84, let's take 26. What is the answer? Answer is nothing but cannot be determined. You cannot determine because you get different reminders in different numbers. Now how will you solve this question? What they're saying is if you divide into a group of 9, nothing is left out, right? So what is the first number? 9. And if you divide into a group of 11, 7 is left out, right? So what is the first number? 7. So how will you write this? What is n? N, if you want to generalize, n is equal to 9. If you divide with 9, there is no remainder. Or if you divide with 11, there is a remainder of 7, right? Now, there is nothing common, this is not belongs to the first type or second type. First type is when the remainder is common, so here obviously remainder is different. Second type is when the divisor and the remainder, if you take the difference, it should be same, right? Here it is different. So this belongs to the third type, so where we need to manually found it, right? So what is the first series if you expand 9a plus 0, what are the possible numbers? 9 is the first number, 18, 27, 36, etc. it will go, right? Now we need to see what are the numbers which belongs to the second series. And what is n? N is a number which comes in both series because n has to satisfy both the condition, right? So we are finding this as 7 and 18 and then, okay, but 18 itself you got the answer, right? So what is this 18? 18 means it will come in both series, right? That means 18 when divided by 9 leaves a remainder 0. 18 when divided by 11 leaves a remainder 7. So 18 is the first number which satisfies both the conditions. So you can pick your first possible number. If it is asked, 18 is your answer. If the question is about the first possible number, which the first value that n can takes place, 18 is the answer. But what is asked here? You have a shelf of capacity of 1000. What are the different values n can take place, right? Or they're not asking you what are the different values n can take place. They're asking you how many different values n can take place, right? So you understood that the first possible number is 18. Why? 18 I can write it as 9a plus 0, 11b plus 7. What does this mean? Divide by 9 leaves a remainder 0. That means arrange them in a group of 9, nothing left out. Arrange them into a group of 11, 7 left out. That's what I mean by divide by 11 leaves a remainder 7, right? What is the next number which satisfies this condition? That will be you need to see the LCM of two divisors, right? That is 99. So the next number will be 18 plus 99. Now we have already discussed this type of question. Now this is going to make an AP, right? With the first term 18 and a common difference of 99. So you got the first term as 18 and the common difference as 99. What you need to find out is how many different values n can take place. The first value for n is 18. So how many different values n can take place? So different n values will have a common difference of 99. So if you need to find it directly, you can do this. Divide by 99. So n can be either 10 or 11. Now you look into option. If in your option both 10 and 11 is there, you need to solve in a different method. Okay, then it may be a round 2 question because you may take some time for calculation. Otherwise, if you look here, you have only one option. 10. You will pick 10 as the answer. You don't want to do anything, right? What you have done is you understood that 99 is the common difference. So 1000 is the capacity. So within 1000, how many different numbers I can arrange with a common difference of 99? It is either 10 or 11. So if you look into options, you see 10. So you can pick 10 as the answer. If both are there, you need to solve it, right? So how will you solve it? What is the first number? First number is 18. Next number will be increasing in steps of 99, right? That will be 117. Then it will be increasing like 216, etc. It will go. So, or what else? Then you can find the last term, right? Then you can find the last term. So after getting first and last, then your answer is ready, right? You know the number of terms in an AP is last minus first divided by common difference, right? And plus 1. Or what you can do, rather than finding last term and all, what you can do is just put n is equal to 10 here. This is just random, like randomly you are just putting a value, right? See, this is what? 18 plus 99k, right? Now you put k is equal to 10. What you'll get? 990 plus 18, right? So that is nothing but 1008. That is greater than 1000. So I'm looking for a number less than 1000. So if your k is 10 means what? K is 10 means what? K is actually n minus 1, right? So what is n? N is 10. I hope you understood. See, if you are finding nth term, that is 11th term, how will you proceed? A plus n minus 1 into d. That is what? A plus 10d. That's what I did here. I put I put k is equal to 10. What I am actually getting 1008 is actually 11th term. So 11th term is not possible. So previous will be possible. That's why I wrote answer is 10. Or the first term, that is 18. Then it will increase in steps of 99k. So first term is 18. Find the last term, right? How will you find last term? You got just now you got it as 1008, right? So 11th term is 1008. So previous will be 99 less. How will you get that? That is nothing but 909. So now what you need to do? Last minus first. 909 minus 18 divided by 99. That's what you need to do. 909 minus 18. You can do that, right? 899 minus 8. 891 divided by 99. You get 9. 9 plus 1, which is equal to 10. So in any way you can do. But the best approach is, you understood that it is 1000 term. You need to see how many terms will be there in 1000 with a difference of 99. You just divide. So you understood this is 10 or 11. So if your options having both 10 and 11, you keep it for round 2, because you may take some time for calculation. If you have one of the option, just pick that as the option. There is nothing to do, right? Now divided by 7, 3 is the remainder. What does it mean? What is the first number? 3. 3 divided by 7, 3 is the remainder, right? What is the next term? Next term will be like increasing in steps of 7, right? You keep on adding 7, you will get the next term, etc. And every such number will satisfy the condition. You divide by 7, leaves the remainder 3. What is the next term? 10. What is the next term? 17, etc. It will go. So what is this? This is nothing but a AP. Now the question is nothing but which is related to AP only, and we had enough discussion about this, right? So what is this? So how will you proceed? Okay, 3, 10, 17, etc. which is going on. So what is the last number? What is the last 2-digit number? Okay, 3 is not the first number, right? We will start from 10 because it is given that 2-digit number. Last 2-digit number is 94. So how you get 94? Basically you are looking for multiple of 7 plus 3. That's how you get remainder 3, right? So what is the next multiple of, what is the multiple of 7? Close to 100, 91 or 98. If it is 98 minus 4, if it is 91 plus 3, right? You get 94. So you know the first term, the first term is 10, the last term is 94. You can find the number of terms now, right? So 94 minus 10 divided by common difference, which is 7, right, plus 1. Last minus first divided by common difference plus 1, right? So you get 84 divided by 7, which is 12. So 12 plus 1, which is equal to 13. So you have number of terms 13. Now you have a formula for sum, right? So what you will do, sum, what is sum? Sum is equal to n by 2 into first plus last, right? So first 10, last 94, right? N what is that? 13. And divide by 2, right? So this is nothing but 13 into 52, you get 676. Okay, what is the question? 4 raised to 96 divided by 6, what is the remainder, right? So we can use the property of 4 here. It's like, so okay, let me start with the, okay, what is 4 raised to 1 divided by 6? You get 4, right? 4 square divided by 6, if you see, again you get 4. 4 cube divided by 6, you get 4. 4 raised to 4 divided by 6, again you get 4. So basically, if you take any power, 4 raised to any power divided by 6, you get remainder as 4. So here 4 raised to 96 divided by 6, what is the remainder? 4 only. So you can generalize it, 4 raised to any power divide by 6 leaves remainder 4. Now what is this question? A number when divided by 4 and 6, 7 leaves a remainder 2, right? So in each case leaves remainder 2. What is the number, right? That's what they're asking. So how will you write this? N as a number which when divided by 4 means 4a plus 2, right? Leaves a remainder 2. Which when divided by 6 means 6b plus 2. Which when divided by 7 means 7c plus 2, right? I hope you understood, right? When divided by 4 leaves remainder 2, divide by 6 2, 7 also 2. So this is type 1 that we have discussed, remainder same. Your answer is LCM plus the remainder. So here LCM of divisors 4, 6 and 7 and plus remainder here is 2, right? So 84 is the LCM plus 2, that is 86 is your first term. If the first term is what asked, right, what is the minimum possible value or what is the smallest such value, your answer is 86. Now everything else which can be asked from this, you know, right, when you get the first value which is 86, now it is going to get a or make a series of 86 plus 84k, right? Why? Because 84 is the LCM. Now they can ask you any question which can be asked from an APA, right? So they can ask you the first term, that's what asked here. They can ask you the common difference is nothing but LCM of divisors. They can ask you the nth term, right? Nth term means, let's suppose 11th term is asked. Nth term is a plus n minus 1 into d, right? If it is 11th term, a plus 10d. What is d here? 84, right? What is a here? 86. So substitute, you can get a plus n minus 1 into d. That means nth term. They can ask you how many different terms are there in a range of 1 to 1000. So find the last term within a range of 1000 and last minus first divided by common difference plus 1, you'll get the answer. Now next question, you need to find the rightmost non-zero digit of 30 raised to 2720, right? So to find the rightmost non-zero digit, you are not interested in this, so you'll write it as 3 raised to 2720. And you know, this is the number is ending in 3, power cycle of 3 is 4, or the frequency is 4. So you need to divide this bigger number by 4, right? You take out the power, you divide by 4. So rather than, and you need to see the remainder, right? So rather than dividing the 2720 by 4, you can divide by 20. Right? So last two digits only, because the divisibility rule of 4 says that, right? So you can even write it as 3 raised to 20. And then what you need to do, take out the power, divide by 4, see what is the remainder, 0 is the remainder. So this you can write it as 3 raised to 4. What are the possibilities in case of 3? 3 raised to 1, if it is 3 square is 9, 3 cube is 7, 3 raised to 4 is 1. I will mark this as the answer, right? So I will mark 1 as the answer. So how will you solve it? 200 raised to 1000 divided by 17. You need to find the remainder. See, direct question. There is some issue towards the end. Otherwise, it's a direct question. You'll apply Fermat theorem and you can solve. You can take the Euler's number and you can solve easily, because if you see this denominator, it's a prime number, so you can find the Euler's number faster. That is 16. You can divide it faster, right? So what is the first step? So if you follow the steps, first step is 200 divided by 17. What is the remainder? 13, right? Then what is the second step? The power of numerator, that is 1000, you divide with the Euler's number of denominator, that is 16, you will get 8 as a remainder, right? What is your actual answer now? 13 raised to 8. But what is the problem? This is greater than 17. So I need to divide it again by 17. Now this is the problem. Now you cannot apply Euler's number or Fermat theorem, right? Because this is reduced. So now you need to do it manually. So what you need to do is, your answer is now, this is your answer, 13 raised to 8 by 17, but this is not there in your option. Now you need to convert this in such a way that you will get it in options, right? So how will you do? See, now we need to solve by using basic remainder theorem. You need to factorize the numerator So okay, you see 17 here, okay. Or what you need to do is factorize the numerator in such a way that when you divide by the denominator, leaves a plus 1 or minus 1 as a remainder. Then it will be easy, right? So if you see here, this is slightly, some understanding is required in this numbers, right? 13 square by 17, what is the remainder? 13 square is 169, right? 169 by 17, you will get 16 as a remainder. Or I can write it as minus 1, right? 16 is nothing but 17 minus 1, right? So I got minus 1 remainder here when 13 square divided by 17. So I'll write it as 13 square raised to 4 divided by 17. Or 13 square is therefore 4 times divided by denominator, right? It should be like this. It can be a revision of your basic remainder theorem also, right? That's why I'm explaining in this way. 13 square into 13 square into 13 square into 13 square. I can write it as 17. Now you need to do it individually, right? And your actual remainder will be the product of individual remainder. And individual case, it will give you minus 1. And 4 such cases raised to 4, right? So minus 1 raised to 4 will give you 1 as the answer, right? So answer for this question is 1. So what we did, your question was 200 raised to 1000 divided by 17. What is the remainder, right? What is the first step? 200 by 17, right? 200 by 17, when you do, you get 13. What is the second step? Power of numerator you divide with the Euler's number of denominator. That is nothing but 1000 divided by 16. You get 8 as a remainder. Now your answer is supposed to be 13 raised to 8 as per what we have learned, right? But this is greater than 17, so you need to divide it again with 17. Now I don't have any method to do this, right? What is the method? Now I can apply basic remainder theorem. So what I did is, I factorized like this, 13 square raised to 4 by 17. Now I know 13 square by 17, this is going to give me minus 1 as a remainder. 4 times, so my answer is 1. Okay, in this question you need to find the last 2 digits of 7 raised to 2008, right? So 7 raised to 2008, last 2 digits is what you need to find out. So number ending in 7, what I need to do, I need to convert this number ending in 7 to a number ending in 1, right? So I need to make it as 7 raised to 4, so that I know this number is going to end in 1. Why? Because 7 raised to 1, if you see 7 square is 9, 7 cube is, last digit is 3, 7 raised to 4 is 3 into 7, 1. Why I am doing it? Because I know the method for finding the last 2 digits of a number ending in 1, right? If I know the previous digit also. What is that? If it is 21 raised to 23, number ending in 1, right? So last digit will be 1, previous will be 2 into 3, 6, right? I know the method of finding a number ending in 1. So what I am doing is I am converting number ending in 7 to a number ending in 1. Now how I am going to do it? I'll write it as 7 raised to 4 raised to 502. So I am sure that this number ending in this bracket 7 raised to 4 is going to end in 1. But I need to know the previous digit also, right? I am sure that this number is ending in 1, raised to 502 is there, but I need to know the previous digit. For that what I'll do, I will try to find what is the last 2 digits of 7 raised to 4, right? That is what I need to do. So this is nothing but 7 square into 7 square, right? 7 square is 49, so this is also 49. So this is nothing but 49 square, right? And I know 49 square last 2 digits will be equal to 1 square, right? That means your last 2 digits of 7 raised to 4 is 0, 1. 502 will remain the same. Your answer is, last digit will be 1, previous will be 0 into 2, 0. Your answer is 0, 1. You will mark C as your answer. So a quick recap of it, what we have done, 7 raised to 2008, right? So what you will do, you will write it as 7 raised to 4 raised to 502. Why you are writing it so? Because I know the method of finding the last 2 digits of a number ending in 1. So I am converting this as number ending in 1. I know when I am doing it, then now 7 raised to 4 is going to end in 1. But I need to know the second last digit also. For that what I will do, I will just expand it and see what is the last 2 digits. 7 square, I make it as 7 square into 7 square. This power remains the same, right? 502 is there. What is 7 square? 49 into 49. Now what is 49 into 49? That is nothing but 49 square, right? I don't know what is 49 square, but I know what is 1 square. 1 square is 1, last 2 digits of 49 square and 1 square will be same, right? So I can write it as 0, 1. But this power will be there 502. So what is actually you're finding it? What is the 0, 1? This is the last two digits of 49 square, or the last two digits of 7 raised to 4. There are some two more other digits is there, but I'm not interested in that. If you need to find that, you can write it as 24, but that's not required actually. How you get that? We have discussed, right? 49 square, if you need to find minus 25, you get 24. Then minus 50, you get 1. 1 square is 1, right? So 0, 1, 24, 0, 1. What is the property used here? Last two digits of 1 square means 0, 1 will be equal to 49 square, 51 square, 99 square, 101 square, 149 square. So 50 minus 50 plus. Okay, multiple of 50 minus 1 plus 1. If it is 2, multiple of 50 minus 2 plus 2. Like 2 square, 48 square, 52 square, 98 square, 102 square, etc., etc. Right? If it is 10, 10 square, 40 square, 60 square, 90 square, 110 square, 140 square, 150 square, etc. 50 minus 10 plus 10. If it is 13, 50 minus 13 plus 13, right? So starting with 13 square, 37 square, 63 square, 87 square, 113 square, etc. What does this mean? 13 square last two digits will be equal to 87 square last two digits. So you don't know 87 square last two digits. You know what is last two digits of 13 square, right? 69. So you can take it as the answer if you get the question like that, right? So here, I know what is 1 square, I don't want to know what is 49 square. So 0, 1. Then power is there. So I know the method of finding the last two digits of a number ending in 1, right? 1, and previous will be 2 into 0, that is nothing but 0. So you'll pick C as the answer. The last two digits we had enough discussion, right? So number ending in 1, how will you find the last two digits? If it is 21 raised to 34, last digit will be 1, previous will be 2 into 4, that is 8. If it is 1 to 1 raised to 34, this 1 is not important. Finding last two digits, only last two digits is important, right? So again it will be 81 itself. If it is 1 1 2 1, still it is 81. If it is 1 1 1 2 1, still it is 81, right? What if it is 61 raised to 72? Last digit will be 1, previous will be 16, 6 into 2, 12, I'll write it as 2. So here the number is ending in 1. So what if it is 33 raised to 64? Then the number is ending in 3. I don't have a method. So what I'll do, I'll convert this into a number ending in 1, right? So I know 3 raised to 1 is 3, 3 square is 9, 3 cube is 7, 3 raised to 4 is 1, right? So if I can write in terms of 3 raised to 4 or 33 raised to 4, I can get the number in the bracket which is ending in 1. So this is nothing but 33 raised to 4 raised to 16. Now 33 raised to 4 means 33 into 33. 33 square into 33 square, right? I know this is equal to 17 square. This is also equal to 17 square. What is 17 square last two digits? 89. Here also 89. There is nothing but 89 square. I don't know what is 89 square. I know what is 11 square. There is nothing but 21. So basically I'll put this power also now. 21 is what? 21 is the last two digits of 33 raised to 4. I'm only interested in last two digits. There are some other numbers also here. But I got the last digit, last two digits, I can find the answer, right? So 16 means 1 is the last digit, 2 into 6, 2. What if you get 33 raised to 66 or something like that? Last two digits, you will write it as 33 raised to 4 raised to 16. So 33 raised to 64 is covered. Then again 33 square, right? So here by using the previous method you got the answer as 21. Now 33 square last two digits you know, right? And you don't want to know what is 33 square. Here you got the last two digits. Here also you'll get the last two digits, you can multiply. So what is the last two digits of 33 square which will be similar to 17 square? What is that? 89. Multiply this, you'll get the answer. What if it is 37 raised to 128? 7 raised to 1 is 7. 7 square is 9. 7 cube is 3. 7 raised to 4 is 1. So you will write this also as 37 raised to 4 raised to 32. Now 37 raised to 4, how will you write? 37 square into 37 square. This power is there. We will write it finally, okay? You just keep it aside. You will write finally because I am trying to find out the last two digits of this. Let me try to find the last two digits of this, okay? So that is a bigger number. I need the last two digits only. So 37 square, 37 square. I don't know what is 37 square. I know what is 13 square, right? I'll write it as 13 square. This is also 13 square. So this is nothing but 169. So I'll write it as 69. I'll write it as 69. So this becomes 69 square. I don't know what is 69 square, but I'm sure that 69 square last two digits will be similar to 19 square, right? So what is 19 square last two digits? It is nothing but 61. Now, I got the last two digits of 37 raised to 4. Now I can put the power also, right? 32. Now what is your answer? Last digit will be 1 because this is ending in 1. Previous will be 6 into 2, that is 2. What if it is 39 raised to 256? 9 raised to 1 is 9, 9 square is 1, right? So 9 square giving you 1. So you'll write it as 39 square raised to 128. What is 39 square? I don't know. Last two digits. Because I need the last two digits. I know that this is going to end in 1. Right? What I need is the last two digits. Right? So 39 square last two digits I don't know. I know what is 11 square. That is going to end in 21. There may be two numbers, two digits here, but I'm not interested. If you want, you can find it, right? You know that 39 square means, minus 25. You will get 14, right? Then you can do it. Minus 50, you get 11. 11 square means 121. So 25, 21. So anyway, we got the last two digits as 25. 21. This is 25. You can find it from here. So this is 1521, right? So anyway, last two digits is 21. What is your answer? 21 raised to 128, right? That is nothing but 1 and 2 into 8, 6. Your answer is ready.